We're talking about trapezoidal approximation graphs, a brief summary of what we did in the other videos. And we're doing the trapezoidal approximation of y versus x from x equals a to x equals b using 4 trapezoids on equal intervals. And we're really just summarizing the calculation scheme in terms of what we know about individual trapezoids. So we have y versus x. We have some function here, some y versus x function, and we have a coordinate a and a coordinate b on the axis, and we divide the interval from a to b into subintervals 1, 2, 3, and 4, and we're going to, we've seen the notations for the slope, area, and accumulated area of each of the 4 trapezoids in the preceding. We want to move to the ability to express the same information compactly for any number of subintervals. So if we want to divide this into 100 subintervals, we want an expression for that. We're going to let n stand for the number of subintervals, and we're going to try to move toward an expression that would apply to that case. Now, let's just start by going back to the situation we had here. We want to label the altitudes and the width of trapezoid number I. That is the ith trapezoid, whether I be 1, 2, 3, or 4. I stands for the number of the trapezoid. In this case, it could be 1, 2, 3, or 4. Later, if we have n trapezoids, it could correspond to any number from 1 to n. So if I is the number of the trapezoid, then what would we write instead of the y0 and the y1 that we wrote for the first trapezoid? You should think that through before you see what I write. But, well, in the first trapezoid, that's trapezoid number 1, and here we have y sub 1. So if we're on the ith trapezoid, then this altitude here should be y sub I. And if it's a second trapezoid, let's say if it was a second trapezoid, well, yeah, that second altitude would be y2. For the third trapezoid, it's y3. For the fourth trapezoid, it's y4. So whatever I is, if I is a number of the trapezoid, that's got to be y sub I. And if that's y sub I, well, what's this? Well, the subscript is 1 less. You know, if it's y sub 1, then the subscript over here is y sub 0. If you're on y sub 2, the subscript is y sub 1. So we're going to write this as y sub I minus 1. Our width is still going to be b minus a over 4 because we're still talking about these 4 trapezoids. So we have b minus a over 4. Now, how would we write the slope? How would we write the area? Well, the slope is just rise divided by run. The rise now is this minus this, y sub I minus y sub I minus 1. So our numerator is y sub I minus y sub I minus 1. And our denominator is just the width, which is b minus a quantity over 4, which I write this way. Now we know that we could simplify that into simple fraction, 4 times y minus yi minus yi minus 1 over the quantity b minus a. But I'm not going to bother with that just now. We'll use that when we have, excuse me, have a reason to. Okay, well, I did my best to write that down here, but it's going to be the average of your 2 graph altitudes, which is y sub I plus y sub I minus 1 divided by 2, multiplied by the width, which is the quantity b minus a over 4. That's not a square, that's a 2 up here. And I'll write it down a little better up here where I've got a little bit of room, as well as the expression for the accumulated area for the ith, up through the ith trapezoid. Okay, here are the same expressions. Not going to read them to you. They're the same as they were down here, and they follow immediately from this labeling of the trapezoid, from these quantities on the trapezoid. Okay, what about accumulated area of the ith trapezoid. Well, we see that for trapezoid number 2, we have accumulated area 2 is accumulated area 1 plus the area 2. So the 2 matches the subscript here, and this subscript is 1 less. So we have accumulated area I minus 1, which is the accumulated area through the previous trapezoid added to the area of the present trapezoid. Okay, we might also want to write that applies when I is greater than 1. Okay, for the first trapezoid, remember, the accumulated area was just equal to the area of that trapezoid. So we could write AA1 equals A1, and that would give us a complete definition of the accumulated areas of the various trapezoids. Assume we have some way of calculating a y-coordinate if we know the x-coordinate. So specifically, we could calculate the y-coordinate corresponding to point A and the y-coordinate corresponding to point B. And we would call those y0 and y4 for reasons that will become very apparent if they aren't already. Now, in order to divide this into 4 equal intervals, we're going to have to calculate the coordinates of these intermediate points. And we're going to call the coordinate of the first point, which we know to be A, but we're going to call that x sub 0. And then we're going to call the next 3 coordinates x sub 1, x sub 2, x sub 3, and the last one x sub 4. With x sub 0 equal to A, x sub 4 equal to B. The widths of these intervals, if we're using equal intervals, each have to be 1/4 the total width from A to B. Well, the width from A to B is just B minus A, so B minus A over 4 is going to be the width of each trapezoid. Having determined what that width is, we can simply add that width to A to get x1, and then add it to x1 to get x2, and so forth, and we get x1, x2, x3, and x4. So we can easily calculate these coordinates, x1, x0 through x4, if we know A and B. Then we can easily evaluate, as we said before, the y-coordinates, y1, y2, y3, and y4, and y0, y1, y2, y3, y4, so that for each trapezoid, we know the width and we know the 2 altitudes. Well, now let's look at the first trapezoid. And of course, we're going to want to label the slope, the area, and this thing, AA, which we call the accumulated area, and expressed in parentheses just below the area. And we'll talk about what that means in a minute. So the first trapezoid, what do we know? We know it has width B minus A and altitudes y1, y0, and y1. So we easily calculate the slope, the area, and then I'll tell you what we do for the accumulated area of the first trapezoid. And you should write down those expressions without looking at the expressions that I've derived. It's very straightforward. This slope is the rise divided by the run. The run is B minus A over 4. The rise is y1 minus y0. So that the slope is y1 minus y0 over quantity B minus A divided by 4, which could be simplified. This is a complex fraction. Could be simplified to the form 4 times y1 minus y0 over B minus A. The second trapezoid is just like the first, except it has the same width, but it has altitudes y1 and y2 instead of y0 and y1. So we easily calculate the expression for the slope and the area of the second trapezoid, and that can just be done almost mindlessly by replacing y1 and y0 by y2 and y1, so that we have slope y2 minus y1 over quantity B minus A over 4. And you know, a y2 here and a y1 here in the expression. And for the area, we would have a similar result. So, well, okay, the area of the first trapezoid, well, I calculated here, average altitude times width. We know the width, B minus A over 4. Average altitude for the first trapezoid is y0 plus y1 over 2. So the area is y0 plus y1 over 2 times B minus A over 4. I like to keep the 2 and the 4 there because they have meanings, and we don't want to lose those meanings by just using an 8 in the denominator. That's okay once we're really familiar with the meanings and know where that 8 comes from. Okay, so we see that, first of all, we have an expression for the slope of the first trapezoid and the area of the first trapezoid, and we're going to say the accumulated area through the first trapezoid is AA1, which is equal to A1. So we're going to label the area here, and the accumulated area for this trapezoid is the same as the area. Okay, well, we go to the second trapezoid, and again, as I say, we replace y1 and y0 by y2 and y1 in all these expressions, or at least in these 2 expressions, and here's what we get. Now we could sketch another trapezoid and label it with y1 and y2 here, but we would get the same thing, and that should be something you can understand easily. If not, we discuss it more thoroughly in the full video. Single video. Kind of a long one. Okay, the accumulated area, AA2, accumulated area 2 now is accumulated area 1 plus area 2. What's this mean? Well, accumulated area 1 is just the same as area 1, so we're adding the first area to the second, and that gives us the total area from here through here, and that's an important quantity. Okay, well then we go on and do the same thing for the third and fourth trapezoids, and the expressions follow in a very straightforward manner. We'll mention the accumulated area for the third is the accumulated area for the second, which is the area through the first 2 trapezoids plus the third, the area of the third. And I didn't write it down here, and I should have. Let me pause and do that. As you're probably expecting, the accumulated area 4 is accumulated area 3 plus area 4. The accumulated area through these 3 added to this one. So our accumulated areas are total area up to here, then up to here, then up to here, then up to here. Our fourth accumulated area, of course, then is the total area of all 4 of the trapezoids.